Is the Andromeda Galaxy causing problems for the Milky Way? Some of the most fascinating events in the universe are galaxy mergers, supernovas, and black hole collisions. Both have a cool aesthetic. Galactic mergers, however, offer all of that and more. The massive collision of the Milky Way galaxy with the nearby Andromeda Galaxy, predicted by NASA astronomers, will have a profound effect on our galaxy, sun, and solar system. What transpires when two galaxies meet? Do you think it would be pleasant to live in the middle of a merging galaxy, or would everything perish in the process as the stars pass one another? Let's find out. There are some really amazing things that gravity can do in the cosmos. When the invisible force isn't making sure that your coffee spills directly onto your shirt here on Earth, it's busy creating objects out of cosmic matter. Gravity smashes entire galaxies together, transforms clumps of rock into spherical planets, and converts gas and dust into brilliant new stars. A large galactic ball is formed as gravity pulls galaxies toward one another, sometimes two, sometimes more, until they collide. Their contents clash and blend. As a result, these so-called mergers have been observed by astronomers at almost every stage of the process. Initially, the galaxies appear to be gathered for a crucial space meeting when they are grouped together with gravity starting to stretch them out of their natural shapes. In the thick of it, and after all is said and done, a chaotic sphere is what's left. By that time, the faint star material shimmering around the orbs is the only indication that there had once been a merger. Due to the gravitational attraction of surrounding dark matter, collisions between galaxies in close proximity continue to occur despite the universe's expansion and acceleration. Such encounters between galaxies were more frequent in the past when the universe was smaller. According to the deep views of the universe provided by the Hubble Space Telescope, astronomers have found that our galaxy is on the verge of a violent merger that could change the universe forever. The Milky Way and Andromeda, its huge spiral companion, will collide in the future. The galaxies won't last in their current form. In actuality, the solar system will outlive the galaxy. The sun won't be a red giant star by that time, but it will have gotten bright enough to scorch Earth's surface. However, any remaining life forms will be treated to some pretty amazing cosmic choreography. The Milky Way and Andromeda are currently 2.2 million light-years apart. The two galaxies are rushing toward one another at 402,000 kilometers per hour, propelled by gravity. They will smash into one another and pass through, leaving behind gaseous, starry tendrils in their wake. A team of astronomers studied the motions of nearly 7,500 stars in the inner halo of the Andromeda Galaxy, also known as Messier 31 M31, and found patterns in their positions and motions. These patterns indicated that the stars originated as a component of an earlier galaxy that joined M31 about 2 billion years ago. The universe is a dynamic realm. Even though the night sky may appear static, over the course of cosmic history, smaller galaxies like M31 and our Milky Way served as the building blocks for larger galaxies. Andromeda is currently only visible as a tiny dot in the night sky, but in a few years, it will be entangled with our galaxy. The spiral arms of our galaxy and the supermassive black hole will vanish. Our own black hole, which has a relatively small mass of 4 million suns compared to Andromeda's central black hole of 100 million suns, will be quickly absorbed. It will all be over with a bloop. How can we be so certain this will happen? Beginning in the early 1900s, astronomer Vesto Slipher determined the Andromeda Galaxy's radial velocity, or the rate at which it was traveling toward or away from Earth. Slipher accomplished this by searching for recognizable compression or stretching in the Andromeda light reaching Earth. Light from objects moving away from us is slightly stretched or redshifted, while light from objects moving toward us is compressed or blue-shifted. The outcome was quite unexpected. We may conclude that the Andromeda Nebula is approaching the solar system with a velocity of about 300 kilometers per second, Slipher wrote in the Lowell Observatory Bulletin in 1913. Because scientists weren't aware that Andromeda was not a component of the Milky Way back then, it was referred to as a nebula. Slipher's computation strongly suggested that this notion needed revision. It became clear that Andromeda was heading in our direction. At that point, it was still unclear whether its arrival would signal the Milky Way's demise. For many years, it was unknown whether the Milky Way and Andromeda would crash directly or pass one another like star-filled ships in the cosmic darkness. Determining the sideways motion of distant objects, or what astronomers refer to as proper motion, is significantly more challenging than determining velocity toward or away from us. When something is far away, quantifying its sideways velocity is difficult because it doesn't create recognizable stretched or compressed wavelengths. Instead, astronomers rely on meticulous observations of an object's position in relation to background stars. Without superior telescopes, it may take centuries for this subtle shift to become apparent. Using simulations of the approaching collision and merger of Andromeda and the Milky Way, researchers like Avi Loeb and later postdoc T.J. Cox used estimates of Andromeda's proper motion. Their findings indicated a strong likelihood of the two galaxies colliding and suggested the solar system would be pushed to the periphery of the new elliptical galaxy. In 2012, the collision calculations were revisited by a group of astronomers from the Space Telescope Science Institute, who used direct measurements of Andromeda's proper motion. This time, the scientists employed the Hubble Space Telescope and an observing program utilizing years of data, starting with photographs taken in 2002, to obtain those measurements. After all those years, we compared images taken at different times with the Hubble Space Telescope and measured how much the Andromeda stars have moved relative to the fuzzy galaxies in the distant background, says astronomer Sangmo Tony Sohn. This gives us a sense of how fast the Andromeda stars moved across the sky. The crew concluded that Andromeda's proper motion was extremely slight, making a head-on collision almost certain. Although merging galaxies might sound frightening, it actually happens quite frequently. Astronomer Halton Arp included several galactic interactions in his 1966 book Atlas of Peculiar Galaxies, featuring photos of distant mergers and collisions taken by the Hubble Space Observatory. These images are all quite striking. The Milky Way and Andromeda will continue to come together and fly apart for ages, rearranging constellations and jumbling stars, until after about 1 billion years the two galaxies will finally unite. When the Milky Way and Andromeda collide and merge, a large elliptical galaxy will be created, giving the solar system a new location in the cosmos. This is a true scientific forecast, not a science fiction chapter. The third episode of Cosmos, a spacetime odyssey focused on how science might predict such events. It was a mathematical understanding of the physical principles governing the motions of celestial bodies that allowed Newton to explain planetary orbits, Halley to predict the return of his comet, and modern astronomers to predict the end of the Milky Way. Using nothing more than Newton's law of gravitation, we astronomers can confidently predict that, several billion years from now, our home galaxy, the Milky Way, will merge with our neighboring galaxy, Andromeda. Because the distances between stars are so vast compared to their sizes, few, if any, stars in either galaxy will actually collide. Any life on the worlds of that far-off future should be safe, but they will witness an incredible billion-year-long light show, host Neil deGrasse Tyson explains. The situation is akin to a batter viewing an incoming fastball in baseball. Despite Andromeda's more than 2,000-fold quicker approach, it will take 4 billion years before the strike occurs. It will take the interacting galaxies another 2 billion years after the encounter to fully merge under the pull of gravity and reshape into a single elliptical galaxy, similar to the kind frequently found in the local universe. According to computer calculations based on Hubble's observations, even though the galaxies will collide, the stars within each galaxy are so far apart that they won't crash into one another. However, the new galactic center will force the stars into various orbits. Simulations suggest that the solar system will be thrown significantly farther from the galactic center compared to its current position. M31's tiny companion, the Triangulum Galaxy, M33, will also be involved in the collision and may eventually merge with M31 and the Milky Way, further complicating the process. It's even possible that M33 will collide with the Milky Way first. Although mergers won't produce noticeable changes in a person's lifetime, they nonetheless present astronomers with exciting opportunities. Being alone in an unconnected galaxy can have its drawbacks. For instance, due to the presence of too much gas and dust, Earth's location in the Milky Way does not provide the finest vistas for studying our galaxy. To understand the behavior and evolution of spiral galaxies like ours, astronomers must study other spiral galaxies. If another spiral galaxy were much closer and tilted in such a way that most of it could be observed, it would be much easier to study than our own. However, during a galactic merger, the night sky would be too crowded to examine very distant celestial events, making it frustrating for astronomers. It would be challenging to locate lines of sight unaffected by the luminous merging system that would serve as our home. Someone else might have gazed at the Milky Way from the midst of a brilliant cosmic collision and wondered what it might be like. The good news is that even if galaxies merge, stars are so far apart that the likelihood of stellar collisions is low. According to simulations, in the worst-case scenario, the Andromeda galaxy collides head-on with the Milky Way, scattering stars into various orbits. Both galaxies' stellar populations are displaced, and the Milky Way loses its characteristic pancake-like form, with most of its stars orbiting on nearly circular paths. As the centers of the galaxies merge, The stars settle into erratic orbits, giving rise to an elliptical galaxy. Therefore, even though Earth will no longer call the Milky Way home, it's likely that the Sun and its planets will survive the birth of Milkomeda. We won't live in a spiral galaxy anymore. Milkomeda will be elliptical and likely appear red. This merger will undoubtedly be a cosmic spectacle. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing content.